Continuing with 1.7, remember last time we were checking if the given matrices M1, M2, M3 are if they are linearly independent or not. So we created these equations. There are 4 of them, but 2 of them are similar, so we just numbered the 3 which are different. So now if I look at 1, from 1, I can either use elimination or substitution method. I'm going to use 1 and 3 because both of them are in same variable C1 and C3. So I rewrite from 1. So I say from 1, C1 is equal to 2C3. So we plug this in the third. Plug in 3. So this gives me 2 times 2C3 plus 4C3 is equal to 0, or 8C3 is equal to 0, or C3 is equal to 0. Okay. So now from 1, C1 is equal to 0, and from 2, C2 is equal to negative C3, so that is equal to 0. So what we ended up is getting C1 is equal to 0, C2 is equal to 0, and C3 is equal to 0. Hence, we say that the matrices M1, M2, M3 are linearly independent. Now, last example is about the polynomials. So we are given 3 polynomials. Let me rewrite them over here. So this is C. I'm going to again give them names like I did to the matrices. So we'll say let P1, well, we can just say P1, we know it's a function of x. So P1 is equal to x squared plus 3x plus 1. And then P2 is equal to x squared plus x minus 1. And the P3 is equal to 4x. Okay, so same thing, we want to check if they are linearly independent. So we say C1 P1 plus C2 P2 plus C3 P3 is equal to 0. So now plug in the polynomials. So we get C1 times x squared plus 3x minus 1 plus C2 times 2x squared x squared plus x minus 1, and then plus C3 into 4x. Now I will distribute. So I get C1 x squared well I forgot to put equal to 0. Okay, so C on the right side. Okay, remember, don't forget this 0. It is going to be very important on the right hand side, 0. So I get C1x squared plus 3C1x minus C1 plus 2C2x squared plus C2x minus C2. And the last one is 4C plus 4C3x equal to 0. Okay, what we do next is we will combine like terms. Okay, combining like terms. Combining like terms. So if you note the C1x squared, there are two x squared terms. One is here and the other is here. So we put them together. We can write as C1 plus 2C2 x parentheses and put it in parentheses and then x square plus. Now the next is the term of having x with them. So we have three of them. So parentheses 3C1 plus C2 and plus 4C3. And parentheses and x. And the last thing is the constant term. So we have just two of them. Plus, now when a term has a negative sign, we are supposed to put it with the, I think I've made a mistake here. This was a plus sign. The first one was a plus sign. So this will be plus C1. Okay. So now we get C1 minus C2. But it was the negative sign. I will put it over here in front of the C1. Okay. So is equal to 0. So now how do we figure out this one? Well, what we do now is we say comparing coefficients. So we are going to look at right hand side, and since right hand side is 0, we are going to think of this as a 0 polynomial, which means a polynomial of the same degree as the polynomial on the left hand side, which is the second degree polynomial, but with all coefficients 0. So we are going to think of the right hand side as 0x squared plus 0x plus 0. So now we say comparing coefficients. So when we compare coefficients, what happens? We get our equations. So we get C1 plus C2, C1 plus 2C2 is equal to 0 because the x squared coefficient on the right is 0. Then 3C1 plus C2 plus 4C3 is equal to 0. And then C1 minus C2 is equal to 0. So this is how we start. This is the process for checking whether given polynomials make a set of linearly independent polynomials or linearly dependent polynomials. Again, now in this case, it would be easier to do it with the equation. So this is equation 1, equation 2, equation 3. So you can see from 1 and 3, we can subtract 3 from 1. So I write it like this: equation 1 minus equation 3 is equal, gives us, so C1 minus C1 cancels out to C2, so we get 3C2 is equal to 0, which gives us C2 is equal to 0. Then C1 is equal to C2, so that is 0. And from 2, because because we have 3c1 plus c2. c1 is 0, c2 is 0. So we end up getting 4c3 is equal to 0, so which gives us c3 is equal to 0. For c3 is equal to 0, so c3. So we got all of them 0. Therefore, we have a linearly independent set. Okay, so that's how you should be able to do all these problems.